Okay, so hi everyone, welcome back to CS 2105. And today we are going to talk about the transport layer, specifically on how TCP works, as well as more about RTP. Can anyone tell me what RTP is? We learned already, right? RTP. There are lots of types of RTP. Can anyone tell me what RTP is? Okay, reliable transport protocol. Okay, so we are going to talk about RTP today, basically on how to rely on unreliability. Okay, we know that transport layer builds on top of the network layer. However, we know that network layer service is unreliable. Going further down to like physical stuff, you will see that normally if you pass in like say ones or zeros, if you go into like more of the hardware stuff, it's actually represented by like some voltages. High voltage means like 1, low voltage 0 means like basically 0. So what if sometimes you can like switch around one of the voltages and then you will have the bit errors directly. So we see that down here is unreliable. If a shark suddenly cuts down the internet cable, then you can't transfer data already. And now what can we do to ensure that within this unreliable channel, we can create a reliable transport protocol? So what does it mean to be unreliable? Why is it unreliable? Anyone can tell me? Actually, I'm not sure why is it unreliable. Okay. Okay. A network is called unreliable for this module is if it can corrupt packets, also if it can lose packets. So for this module, we are going to focus mainly on these two, although you will see that there might be some other aspects also that will be covered in like reliability. So reliable transport protocol is a protocol that will ensure that packets are received by the receiver in good order. You don't want a video with like A, B, C, D, suddenly they will just be received as like E, C, D, B, A and show to the users like that. Okay, so we want to ensure that this protocol will make sure the packets received by the receiver in the correct order. Now, how can we design a reliable transport protocol? Anyone can give ideas on how we can design? Anyone? Random? It's not in the lectures. Actually, only one step. Okay, step 1 to design a reliable transport protocol is to actually understand what do you need in the first place. What is the environment like for you to actually transfer the data? Okay? And second thing is just once you know the environment, you can just whack it out. Since you already know what you require, just implement. Okay? So we talk about reliable data transfer, RTP 1.0. In 1.0, what is this case? Can anyone tell me what is RTP 1.0? No corruption, no loss. That is correct. So RTP 1.0 means that the packets will definitely arrive and it will arrive in good condition. Okay? Similar to, for example, I'm standing here with Richard. Hi, Richard. He understands directly, right? There is no chance of corruption, no chance of my voice not arriving to Richard. Okay? That is RDT 1.0. And hence, RDT 1.0 is a perfect case. We don't need to implement anything. Sender will just send, receiver will just receive. And that's about it. Okay? Receiver does not need to acknowledge because you know that the receiver will definitely receive in good condition either. Okay? So this is 1.0. Any questions? No? Okay. If no questions, now we are going to improve a bit to start to introduce one of the environment problems. Let's move on to RDT2. Can anyone tell me what is the constraint in RDT2? What is the environment like? Flip bits, yeah. Packet loss, is packet loss in 2.0? Do we consider packet loss? Okay, so in RDT2, the current constraint is that the packets will not be lost because it will definitely arrive first. But for 2.0, we are trying to see what happens if the packets can be corrupted. Okay, similar to like, if your baggage comes, then you know that your luggage will be there, but it will be breaking. Okay, how do you handle that item? So RDT 2.0 is basically, as what Cheng mentioned, we'll be handling about bit errors and flip bits. Okay? Now the question is, how do we implement this? What do we do to handle this case? Checksum. Okay, there's a checksum, yeah. So checksum is done on the receiver side to check if actually the data itself is correctly received or not. Then what does the receiver do if the data is correct or if the data is wrong? ACK, NAK, okay? So for RDT 2.0, you can think of it as like two people here, basically Alice and Bob. So Alice will say like, hey Bob, 9 plus 10 is 21. And then Bob will say, okay. Okay, if Bob responds with acknowledge, that means Alice knows that Bob already understands what Alice means. Okay, so Bob needs to acknowledge. On the other hand, if this is corrupted, say something like this, okay, then if you are Bob, what would you do? You will say like, ha, or something, right? Then in that case, that's a NAK lah. So in either cases, Bob will have to respond whether Bob correctly understands or does not correctly understand what Alice meant. Okay, so Bob should also send an acknowledgement to show that he does not understand this. Okay, now, supposedly okay, right? Is there any problem with RDT 2.0? Bob's message can be corrupted. That's correct. We consider that Alice's message is corrupted, but we haven't considered what if this NAK itself is corrupted in the first place? What if it cannot actually reach Alice and Alice cannot understand this? So something like here. If the ACK itself is corrupted, then what can we do now? Actually, is there a problem with this? Why is this a huge problem? On Alice's side, right, if Alice knows that, oh, Bob sends an acknowledgement, but the acknowledgement is corrupted, then on Alice's perspective, of course, I will have to retransmit this packet, right? I retransmit this packet. But if I retransmit this packet, I say, hey Bob, 9 plus 10 is equal to 21 again. Will Bob know the difference between the first packet sent and the second packet sent? No. So what do we do to mitigate that? We add the sequence number, that's correct. So in RDT 2.1, we are basically fixing 2.0 by adding a certain number, a certain ID to each packet. So that in the sense that when the ACK or the NAK is corrupted, you can always retransmit the packet and the receiver will know if this is the same packet or if this is a duplicate, if this is the same packet or a different packet. Okay, so the sequence number is basically for Bob to actually identify if this is a new packet or a duplicate packet. If it's a duplicate packet, then Bob can just drop it. Okay, something like this. Then, yeah, Alice can just send this. Hey Bob, 9 plus 10 is 21. Bob knows that 1 has been received, so when 1 comes again, he can just ignore. Any questions? No? Okay. Now, RDT 2.1 is working for bit errors. But the thing is, if we now have sequence numbers, then do we need an NAK in the first place? So that is something that we are going to improve in 2.2. 2.2 is basically a NAK-free protocol. That means we are not going to use NAKs, but rather we are going to refer to the last packet that is received correctly by Bob. Okay? So something like here, 9 plus 10 is 21. Then instead of just ACK, Bob will tell that, okay, I received packet 1. Then the next time, say packet 2 is being sent, something like this, where it's corrupted, then Bob can just say that I already received packet 1, but I haven't received packet 2. So basically just send the ACK 1. That is the last packet received. Then by saying ACK 1, Alice will know that 1 is received, but 2 is not well received yet. So Alice can just say, hey Bob, 2 plus 2 is 4 as packet number 2, and this will go ACK 2. Okay? Any questions? Okay, if no questions, now we move on to the final part, which is RDT 3. And what are the environment in RDT 3? What is the environment here? Okay, I didn't catch that. Packet loss, okay. Yeah, so his packet is actually lost when transmitting. So in RDT 3.0, the packet may be lost, the packet may be corrupted. Okay? It may be broken, it may be lost. We want to handle both of these cases. Oops, I think I just copied it. Okay. How do we handle this? I think 3.0 is actually the most logical one, in my personal opinion. It's like, for example, you are in a Zoom session, right? Say I'm here and then there's Melissa there. Okay? I will say, hi Melissa, 9 plus 10 is 21. But in a sense, Melissa is not responding there. She just glitches. Okay? Of course, I will say like, hello, hello, something like that, right? So after a certain time, when I see that Melissa is still glitching, then I'll just resend the same item. So RDT 3.0, the special case is that it will have to keep track of when the last packet is being sent. If it exceeds that certain timeout, then that's the time you will have to retransmit the packet. Okay, so RDT 3.0, it will basically store a timer. Any questions? Easy, right? Okay. Yeah, so this is in a nutshell of 1 to 3. I'm not going to cover pipeline protocols for today because I think that will take quite some time. But pipeline protocols is basically just improving RDT 3.0 by pipelining them together. There are 2 types of pipelining protocols. Can anyone mention? Has it been covered? Yep. What are those? Go back and? Starts with an S. Selective retreat. Okay, so both of them are like similar to like sliding windows if you have worked with like some deep code problems. And yeah, I will be covering them in a next opportunity, I'd say. Okay, yeah, so that is that. Now we are going to move on to the tutorial questions. We have 7 questions for the day. First one, I will not ask any question in this case. So we are going to do a very quick demo. Okay, I'm pretty sure you have already tried the network section also. Something like this. Okay, so in this demo, we are basically going to the Chrome or Safari or whatever you use. We are going to this network section. Okay, you will see that there's like some waterfall here and also all the packages received there. What we're gonna do now is we are going to submit a form. Okay, so CS2105, which grade do you expect to get for this module? Anyone? B plus? SU? If it's COVID period, yes. Anyone? Okay. My expectation for you is to get A plus. Okay, my expectation for this class to get A plus. Now we submit this. Okay. Now once we submit this, before we open the network page, can anyone tell me what is the method that is being used to send this data once you submit? Post. Okay, so we are going to see how do we know that this is a post method. If you go up here, you will see that there's this form response. Status 200 means what does status 200 mean? Okay, that means this is well submitted, well received. So if I double click on this, whoops. So if I click on this, then you will see on the header side there's a request method that tells you this is a post request. Okay, up to this point, any questions? Clear on how to access this? Okay. Now, we know that this is a post request. Yeah. What is the difference between post and get? Yeah. It's okay. Raise hand. Yeah.
Sending the data from like so you'll just send the data, but if get is like we're just requesting data.
Okay, if post is you send data, get is you request data. What if I have get but I use query parameters? Technically I'm sending data also, right?
I mean, that's fine, I know, right? Technically you're sending data. I feel like if you use the get method, right, I think the body will
Yep.
that's what I know.
Yep, that is correct. So actually, both of these can send data, that is correct. However, the post one will have its own body. Okay? Actually, what is the difference? Post is basically used to tell the server to store this data set. As compared to, for example, if you use a get method. A get can contain query parameters. However, these query parameters will not be stored on the server. If you use post, then you actually tell the server to store this data. You send the data, server will store this. So yeah, that is as what Marisa said. In contrast, get is basically to retrieve information from the server. Any questions? Yeah. So there are some other request methods. Put patch and also delete. How are these going to be used? Some extra information here. Get is to retrieve data or retrieving an object. Post is usually used if we want to submit a form, which if you learn some backend stuff later on, you will see that this will actually create a new object inside the database. So whenever you create this new entry inside, then most of the times we will use the post method. Put method is for updating objects. Patch is if we want to update objects partially. That means you don't want to update every single key, then we can just partially update something. That's when we use patch, and I think delete is quite self-explanatory. Okay, any questions? Some extra stuff lah. Okay. Okay, now we move on to question 2. Suppose that your department has a local DNS server for all computers in the department. Now you are an ordinary user, you are not an admin, you are not a technical service person. Can you check if someone from your organization has just accessed a certain website? Who says yes? 1, 2, 3. Who says no? 1, 2. Okay. For those who say no, why?
Because of brief recollections from 2107 which I cannot recollect.
Okay, 2107 stuff, okay. Those who say yes, why?
The local DNS will cache if someone accessed it, and then if you access again, it will take less time to get the IP.
Okay, so there's a local DNS. If someone accesses it, then local DNS will cache this.
IP address.
The IP address, yes.
And then if you access it again, then the time will be to get IP.
So if you're accessing it again, then technically it will not query all of the above, just return from the cache. That makes sense? Now the problem is, can we access this local DNS as a ordinary user? So just now there's a concern, 2107 says cannot collect this, right? Then now Cheying mentioned that if you can get the cache from the local DNS, then it will work. Now the problem is, can we get from the local DNS?
Clarifying question. Do we need to know who accessed it or just that the website was accessed?
Just whether the website is accessed. We don't need to know the person. Because if we want to know the person, then renders ideal cannot. Can we access, can we get the data from the local DNS cache?
Don't need to get from the cache. You can just try to access the website again.
Try to access the website again. Okay, so yeah, we can actually access the website again, but there's a better method to actually get this instead of having to open your browser and then get each of the website. So I will do a very quick demo again. I think today's lab is more demo, I think, more than questions. Let me just go to my terminal here. Oops, I think I'll just use this. Can someone give me a website? Google.com, okay, that's quite basic. Okay, maybe let's do a better website. Let me just do my own personal website. So in this case, we can use this command, which is called dig. Okay, can anyone tell me what dig does? Dig is similar to NS lookup, but it will provide you like more detailed answers also, telling you the non-authoritative answer, also the authoritative answers are. And in that case, you will actually see what are the entries, like the C name, the A itself. What is a C name? Have we studied that in lecture? C name? C name is canonical name. A is address. Okay? There's also MX, which is mail exchange. So these three will definitely come out in one of the midterm or finals. Okay? Make sure to know all these. So let me just say dig. The type, I will try to dig the address. Okay, so A is address, T is type. Then I will try to dig, say, my personal website. Now you can see that when it queries, the query time is 15 milliseconds. Okay? Then it will show me like the entries here, which are the addresses here. Okay? The answer section. Now, if I run this again, do we see the query time changing here? From 15 milliseconds down to 9 milliseconds. If I happen to get a 9 millisecond on the first hit, then I know that someone else would have been accessing this before. Okay? So by comparing the query time using the dig command, I can actually see if someone has accessed the website before or not. Any questions? So yeah, Chaying's idea is correct here. We can actually compare the query time. We don't need to actually get the cache items. However, we can directly do a dig command. Then we can compare the query times. Okay? Since,
How
yeah.
do you know it was a couple seconds ago and not maybe an hour ago or before the cache was expired?
There's too many variables.
That is correct. That is correct. So, here's my personal idea since it's not covered in the answer key. You do two dig commands. If both of them are similar, then technically it's directly from the cache. It can't be, say, if the first one is 15 milliseconds, the other one is 9 milliseconds, then technically both of these will be, one is sent, the other one is directly from the cache. If both of them are very similar, like difference of 2-3 milliseconds, then that's the time both of these are from the cache. Then you know that someone has accessed it before already. So you can actually see a direct comparison there. If it's too far, if it's going too far, then technically you will, in a sense that, okay, how should I rephrase this? If the difference is quite tiny, less than 10 milliseconds, then you know it's directly from the cache. Because it's very similar.
I think his question was, how do you know someone accessed it like 5 minutes ago versus now?
Oh, okay, that's a good question.
The question
Oh,
said couples
okay. We don't know. We don't know. That depends on the TTL of the DNS cache. So whenever a DNS cache entry is entered in the local DNS server, then there is a time to live. So this time to live will tell you how long the cache will be there. So when you try to query this, if the time to live is still there, then technically the person accessing it will be between the range of 1 millisecond to that whole time to live in the first place. So we can't know for sure when the person accesses it. Okay? Does that answer? Yeah, okay. Okay. So this is something to see. You can see the query time also. So it might differ from each different queries, then you can just make two different queries to compare one by one. Okay. Then dig command. The -t here is actually a flag that tells you what type of dig command you want to use. And abc.com is basically the name here. So these are the query types that you can use here, as well as what the output will be for the dig commands. Now, you're given 4 programs: TCP echo server, client, also for UDP. Suppose you run TCP echo client before you run TCP echo server. What happens? Has anyone tried this? Does anyone know where to find the files? Wow. Okay, let me just show you a quick one. If you want to find the files, you can actually go to Canvas, and then on the tutorials folder, you will see there's a tutorial 3 files. Then those are the 4 different Python files. For time reasons, I'll just demo this. So, okay. It's not this one. Okay, should be here. Okay, so let me open tcp echo client.py. This is basically a Python file that simulates TCP client here. So you have learned from the lectures about socket programming. This is basically just reiterating what the lecture has been teaching you. So if I try to run this, oops, you will see that there's an error here that tells you connection refused. Why? Why can't I run TCP echo client before the TCP server? No such server port. So basically, this tells you about what TCP actually does. So TCP will ensure that there's a reliable communication. In short, if a client wants to communicate with the server, the client should ensure that the server exists in the first place. Hence, if the server is not started yet, how can you connect to the server? That's the time this will actually encounter an exception. Okay? So when creating a local socket, client will attempt to make a TCP connection to the server itself. This is because TCP is a connection-oriented protocol. Okay? Any questions? Any questions? No? Okay. Now, what if we run, oh, sorry. What if we run UDP echo client before UDP echo server? What happens? I think it's obvious. Anyone? Can just give a very quick guess. What if I run UDP echo client before UDP echo server? Does this work? Can? Who says yes? Listen. Who says no? Okay, I think majority says yes. Moment of truth. Okay, it works actually. So you can just type in anything. Then you will see that it will just idle. So in this case, right, actually the packet is already being sent. But sent to where we don't know. Okay? So this is basically UDP. As compared to TCP, UDP is a connectionless protocol. You don't have to establish a connection to the server when you want to create this local socket. Hence, it's fine if you want to start the client first, then you start the server. Any questions? Yeah, so this is a comparison of TCP and UDP. TCP is you have to ensure the receiver is ready to receive the data. UDP is just yeet, just throw away the baby and then whether the receiver receives or not, you don't care. Okay, that is TCP and UDP. Now, suppose a process in host C, it has a UDP socket with port number 6789. Suppose now A and B will send a UDP segment to host C with the same port number here. Will both of these segments be directed to the same socket at host C? Who says yes? 1, 2, 3, 4. Okay, majority. Who says no? Okay, can I hear from anyone who says yes? Maybe from this side? Why yes?
Everything will go to the same socket.
Okay.
You don't have the idea of.
Okay, yep, that is correct. So UDP itself, it will only have one socket. If anyone wants to connect, it will still reuse the same socket. As compared to TCP, which will create separate sockets for each connection. Okay, so yeah, that's correct. Both segments will be directed to the same socket. As for how you can actually learn if they are from different hosts, there are some APIs for socket programming which you can actually get the IP address of the origin of the packet. Okay? Yeah. So this is basically the lecture. You see that for UDP socket, server will only use one socket as compared to TCP, which creates a new socket for each client. Okay? Just a very quick normal exam question. Suppose this is a server. Then I have like multiple clients. Each client has one connection. Say suppose if I have 50 clients. Each of them one connection. How many sockets does the server create? TCP. 51? Agree with 51? Agree? Why 51? Maybe from others who agree. Because I know you might know. Others who agree, why 51? Okay, there's an extra one for the welcome socket. Afterwards, if they want to create a new one, then this will actually create another socket. Create another socket, create another socket. Okay? So do remember that there's a welcome socket first. This is a very common exam question. Okay? One welcome socket, then each of the connection will actually create one more socket. So total will be 51 sockets here. Any questions? No? Okay. Yeah. So before that, actually I want to ask a very quick question here. I hope I have time to discuss. What is the difference between socket and port? We've been talking about ports, we have been talking about addresses, we have been talking about sockets. What is the difference? Anyone? Okay, I'll show a very quick analogy here. Let's say this is a house. Okay, a house will have, say, okay, let's say it's not a house. Let's say it's a hotel. This hotel will have many rooms, right? Room 1, room 2, room 3. Say this one, room 1 is like Richard, then room 2 is like Raj, room 3 is like Isaac here. Okay? So if I want to address to this hotel, then I will need the hotel's address, right? If I want to send a mail or something. So there's a hotel address here. And then each of the rooms, they will have the room number. Okay? So this room number is basically your port. This address is your IP address. Now what does the socket come in? The socket is actually inside the room. If Richard is inside and then Richard is using a phone, this phone is basically the socket. Okay, so this phone is basically the socket. How does it work? If Richard is running UDP, if all of Richard's friends wants to contact to Richard, right, then technically he can just use the same phone, open Telegram, multiple chats. That is one socket for UDP. Same port, same address, one socket. If, for example, Raj here is running TCP, then in that case, he will have one phone. Whoever wants to communicate with Raj will tell you, okay, he will contact this phone first. After he contact this phone, then Raj will say inside Raj, then there's like multiple friends. Each of them will help Raj contact the friends. Okay, so these are multiple different sockets inside. Still within the same room, within the same port, but now there will be multiple connections. Okay, so now this tells you that socket itself is actually just a software abstraction. Okay, socket does not have anything to do with the hardware here. It's just an internal abstraction that manipulates the connection. We know that each socket would need 3 items: your protocol, the port, and the IP address. But internally, socket is just a software. Any questions? Understand? Okay. I just learned this also quite recently. It's from a past TA also. So yeah, this is basically what socket and port is. A socket is just software abstraction. For a socket to be created, it has to have the port, IP address, and also which protocol it's using. Because if the protocol is different, then the way you are going to use it is also going to be different. Okay? Now we move on to question 5. Suppose you have the following 2 bytes. What is the ones complement of the sum of these 2 bytes? Just checking, has anyone here who takes 2100 already? I know she take 2100. Okay, takes 2100 already. Already? Okay. Then this should be easy. What's the ones complement?
I have a question for the
Yep.
this part. So when I establish a TCP connection,
Mm.
so let's say I have a socket inside a port, as you say, but then when I hand over that to another socket, is that socket within the same port, or am I usually like assigning a different port ID for my new TCP connection, and then the client is communicating with the other port?
Okay. So usually in the case, it will be still binding to the same port. It will still bind to the same port.
Is it the like unique identification as like client IP, client port, server ID, server port? So in that case, won't we have same identification for two or multiple? Like let's say the same client opens 2 connections to the same server.
Mm-hmm.
So then I have client ID, port ID as same, server IDs, server IP, and server port as the same. So I won't be able to distinguish which connection it is.
Okay. So you're saying if a client has like multiple connections to the same server,
Yeah, then it must redirect to a different port. It can't handle on the same port.
okay. Actually, on this, I'll check again with you. I'll check again on this. Yep. That's an interesting question. I'm interested to know also. Okay.
But you can have multiple connections. You can have.
You can have it. You can have like parallel connections also. Yeah, can parallel ones. So in that case, I would suppose that. I would suppose that if someone is making multiple connections, then technically it will be from different ports. I suppose.
Not really. So like I was working on this over the summer, so that's why I kind of.
Mm. I will check this also later. Yes. I never thought of this before. Yep. So yeah, I will check this. Thank you very much for the question, Raj. Okay. Now, question 5. Can anyone tell me what is the sum? What is the checksum? I think it should be easy. Maybe for those who haven't spoken, I think quite easy here. Okay, let's hear from Brian, maybe. What is the sum for this? Not the checksum. Okay, maybe those on the my very left there. wherever that is.
The sum will be 11000000, right?
11000001. Okay, so maybe we can start from right to left here. 0 plus 1, this will give you easily 1. Okay, since it's a binary addition, 0 plus 1 is 1, 0 plus 0 is 0. However, 1 plus 1 will give you 1, 0, right? So the 1 will actually be part of the carry here. Then 1 plus 1, 0, 1 again. Again 0, 1. Again 0, 1. Now this will become 1, 1. Then 1 plus 0 plus 0, this will give you 1. Okay, so this is the sum. Now, can anyone tell me the ones complement of this? Maybe for Calvin?
Just flip it.
Just flip it. Can you flip it?
0, 0, 1, 1, 1, 1, 0.
Okay, so you flip it, this will become 0, 0, 1, 1, 1, 1, 1, 0. Okay, should be easy. Easy, right? Okay. Now, what if we have these 2 bytes? What is the ones complement? Maybe can anyone else? I think quite easy question. Maybe from Carmen? The sum, the sum. One zero zero.
Oh, sorry. 0, 1, 0, 0, 0, 0.
Okay, so yeah, I think that's correct. So if you sum this up, then at the end, right, there's a carry. What do you do to the carry? You add it again to the front. Okay, that's correct. So in this case, we do the usual sum. We will get up to this point. We will see that there's actually a carry over of 1. Right, so there's a carryover of 1 there. What do we do to this amount of carry? Is basically, we're going to add this over to the least significant bit there. Okay, so if we add this over, then we will get same item, 0, 0, 0, 0, 0, 1, 0. Okay, and finally checksum is easy. Just have to flip this. Then you'll get 1, 0, and 1s all the way. Okay, any questions? I know for this part, maybe Chen can teach better than me. Okay. Okay, that's question 5. Now we move on to question 6. Suppose the UDP receiver computes the checksum for the received segment and finds that it matches the value. So the checksum matches now. Can the receiver be certain that no bit errors have occurred? If the checksum is correct, can the receiver know that no bit errors occur here? If yes, why? If no, why? I see someone shaking head already. Maybe you want to explain?
Basically, I say no, and I just give an example.
Okay.
Let's say, right, the original data is like, okay, I just use 3 bits, so
Okay.
it's 0. So let's say you have like something like 1, 0, 0, and 0, 0, 1.
Okay.
Then you checksum it, right, it becomes like, so 1, 0, 1, it becomes 0, 1, 0. Okay, then and when the data is received, right, so basically they get the same thing, 0, 1, 0. So that means the sum is still 1, 0, 1, right? But if the original data becomes something like 0, 1, 0 and 0, 1, 1, technically it's still the same checksum. Okay, so the bits are flipped. Let's say it becomes 0, 1, 0 and 0, 1, 1.
0, 1, 0 and 0, 1, 1. Okay.
Yes. So technically it's the same, right? But the bit is meant to be, I guess it's still wrong.
Yeah, this is correct. So you can always find a counter example to actually see that for the same checksum, it is not a 1-1 correspondence here. Okay, you can have multiple bytes that when you combine together will result to a same checksum, as what Melissa mentioned. So you can always flip some of the bits. You get a similar checksum here. Okay, so this is a great example. Thank you, Melissa. So yeah, this is a example from question 5. If I modify just one of the bits here, then I will still have the same checksum. But you know that both of the bytes will actually be flipped around. Okay, so the checksum can never be sure if both of these bytes have the bits being flipped. Basically, that's the case here. If only one of the bytes that gets flipped, then most likely it won't be changed that much. But if both bytes will get flipped, then it will fail to detect the error. Okay, any questions? Okay. Now, final question, question 7. In our RDT protocols, why did we need to introduce sequence number? I mentioned already in front, maybe just a quick review. Why should we introduce sequence number here?
Detect retransmits.
To detect
Retransmits.
retransmits, to detect duplicate packets. That's correct. So sequence number is actually used to check whether this packet has useful info, new data, or if it's just duplicate data. Actually, later on, sequence number will also be used to implement protocols that might use reordering. In that case, sequence number will be useful. Okay? But for now, it's for duplicate packets. Later on, you will see that sequence number is useful for reordering. Especially for TCP with like large packets. The sequence number of ACK will actually tell you which certain windows that you have to retransmit data. Okay? Yep. So this is how it works usually from RDD 2.1 slides. And yeah, that's about it for this tutorial. Any questions? Final questions? So if no questions, then that is it for this tutorial. Have a look at the code. I didn't use GPT for this. So thank you very much for attending. If you haven't scanned the QR code for attendance, please do so, or else your attendance will not be recorded.
Curious about, so usually when you open multiple connections, the client side usually assigns a different port. But so my question was more towards embedded systems where you might have very few number of
Right.
client side connections. So
Right.
if from the same client side you try to open two connections, will it work or is it not smart enough to detect that? I'm not sure.
I actually haven't done that before.
I'm
yeah.
also not sure.
So last
Curious.
year I took 05. Then last time I took 07. When I took 07, it's basically one port, one connection.
Uh-huh.
That's what I learned now. But yeah, right now I'm taking embedded systems. But, I mean, if you're interested, this is basically my project today.
Oh, wow. What mod are you doing?
3237 IoT.
Oh, IoT, okay.
I'm taking
My
IoT
friend is
now.
also doing IoT.
Ah, yeah. The lab is
You have to only upload the code and some video of this working,
Right.
right?
Yeah, so this is my current stuff now. Right now, we're still learning about how to establish connection also. I hope I can clarify with you later after I learn this. So sorry for this.
No worries, no worries. Because one of my summer intern projects was also multiple
Ah, okay.
connections.